But before we explain the technology and the outstanding advantages of the CryoMill, we will demonstrate why cryogenic grinding is sometimes the only appropriate solution for comminuting a particular sample material. Samples which are tough, soft, or elastic are difficult or even impossible to grind at room temperature. They only bend instead of breaking. When liquid nitrogen is introduced to such materials, it cools the whole sample down to minus 196 degrees Celsius and embrittles its structure, making it break easily. Moreover, volatile components, which could escape when the material gets warm, are preserved. The CryoMill has been specially designed for cryogenic grinding with liquid nitrogen. Continuous automatic cooling and a powerful drive make sure that even difficult samples can be ground down to a few microns in seconds. Therefore, it is suited not only for hard and medium-hard samples, but especially for elastic, tough, for soft ones like plastics, leather, car tires, secondary fuels, or organic materials like cheese and sausage. The mill is also ideally suited for disrupting biological material. With a maximum feed size of up to 8 millimeters, grind sizes down to the micron range can be easily achieved. The screw-top design of the grinding jar and the unique locking system of the grinding station prevent leaks so that size reduction can be executed safely and without sample loss. Periods of pre-cooling and grinding, as well as the oscillation frequency of the mill, can be pre-selected digitally. For long-term grinding processes, an intermediate cooling period and the number of cryocycles can be pre-selected as well. This guarantees maximum reproducibility of the sample preparation process. After starting the machine, the liquid nitrogen circulates through the cooling system and embrittles the sample inside the grinding jar. Liquid nitrogen is continuously and automatically refilled from an autofill system in the exact amount which is required to keep the temperature at minus 196 degrees Celsius. An interruption of the grinding process is not necessary. The sample container performs radial oscillations in a horizontal position. Thus, the material is hit alternately from various sides by the grinding balls. This high impact and friction action, together with the sophisticated cooling system, makes the Wretch CryoMill much more efficient than conventional, non-continuous cryogenic grinders. All drive components and heat sources are located outside the cooling system, which optimizes the grinding process and reduces the consumption of liquid nitrogen to a minimum. Additionally, the CryoMill possesses exceptional safety features. At no time does the user come into direct contact with the liquid nitrogen. The Dewar vessel offered by Wretch features an overpressure valve in order to make handling even more safe. For universal use, the CryoMill can be operated without liquid nitrogen for dry and wet grinding, like a common mixer mill. To optimize your particular grinding process, the CryoMill can be operated with a variety of jars and balls, ranging from 5 milliliters to 50 milliliters, and from 5 millimeters to 25 millimeters. Both are available in several different materials to allow neutral to analysis grinding. Smaller sample volumes, as commonly used for the isolation of DNA and RNA, are preferably prepared in disposable reaction vials such as those from Eppendorf. For this purpose, adapter racks are available which hold up to 4 reaction vials of 2 milliliters each. Grinding balls and glass beads for use in reaction vials are available in sizes from 0.1 millimeters to 5 millimeters. All these unique features ensure the superiority of the new CryoMill. The convenient benchtop unit is the ideal grinder to prepare difficult samples by using liquid nitrogen. Our CryoMill is an easy-to-use, exceptionally safe, and at the same time powerful tool to conduct perfect cryogenic grinding. It is the optimum solution to obtain reliable and reproducible results for your grinding, mixing, homogenizing, and cell disruption process.